Advanced Math, Lesson 14, Sine, Cosine, and Tangent, Angles of Elevation and Depression, Rectangular and Polar Coordinates, and Coordinate Conversion. First thing we need to know are our trig identities. These are the most basic ones. Also memorized is SOHCAHTOA, S-O-H, let me point here, S-O-H-C-A-H-T-O-H. These are three different equations. Sine of angle equals opposite over hypotenuse. Cosine of angle equals adjacent over hypotenuse. Tangent of angle equals opposite over adjacent. It'll be very common for me while I'm teaching this to just say theta instead of angle. Symbol theta is written like this. It's kind of like an O with a smiley face right on its belly, or like an Easter egg, if you want to think of it that way. It's a more common representation for an unknown angle in mathematics, so I'll probably be referring to it as theta pretty often, just for you to get used to. So those are our trig identities. We should have learned those in Algebra 2 or geometry. We're going to be using a lot of those in these angle of elevation, depression problems, and in our rectangular and polar conversion rates. So let's start with a elevation and depression problem. We'll start with example 14.14. They tell us an airplane is flying at an altitude of 3,000 feet above the ground. Pilot sights an object on the ground at an angle of depression of 26 degrees. Angle of depression being down, elevation being up. What is the slant range from the airplane to the object? All right, and then this is the diagram right here of what they're looking for. So the airplane is traveling on this path, which is 3,000 feet above the ground. They're looking down at a degree of 26. The slant range would be this hypotenuse of this right triangle that is made. So whenever you see an elevation problem, you kind of have to draw the plane of what's going on. So our plane is traveling on this line. The elevation of our plane to the ground is 3,000 feet. The plane is looking down at an angle. Let's see here. This says they look down at the ground at an angle of depression of 26 degrees. So since it's depression, they're looking down at 26 degrees. And since this is also another 90-degree angle up here, that means that this other angle right here is 64 degrees. Now we're going to use our information of this right triangle and using a trig identity to find the length of the hypotenuse, or the slant range, right? We want to know the distance from the plane to the object, right? Straight line distance. So the trig identity that uses the adjacent side to the angle, right? Remember, adjacent and opposite side are always in relation to the angle. Since we're dealing with angle 64, the adjacent side is 3,000. The opposite side would be the ground. We have the adjacent side and the hypotenuse. That identity would be K-A-H, or cosine of theta equals adjacent over hypotenuse. So these are three different unknowns. We're just going to fill them in. Theta being angle 64, so we put cosine of 64 equals the adjacent side of 3,000 divided by the hypotenuse, or the slant range, S, what we're looking for. So then we take this equation. Cosine 64 equals, I'm just rewriting it down here so we can see it better. Once we plug them all in, we have cosine 64 equals 3,000 divided by S. We have to solve for S. One way we could do that is we could multiply each side by S, get it out of the denominator. Now we still need to get S by itself, so we'll divide that by cosine of 64 on each side. That cancels. So then S is going to equal 3,000 divided by the cosine of 64. Once I have this, I can punch this into my calculator. So I'll just take my calculator. Hopefully, okay, cool. And then I'm going to type in 3,000 divided by, I'm going to start a parenthesis line, cosine 64, end parentheses, enter. And I get 6,843.52 feet, and I'm rounding to the hundredths place. 6,843.52 feet. That is the correct answer. Whenever you get long decimal numbers in this class, always round to the hundredths place. This isn't chemistry. We're not worried about sig figures. We don't need extremely long decimal numbers unless we're doing scientific notation problems. So anything like this, just round to the hundredths place. You'll notice my calculator says 516. I wrote 52. I rounded. So that's elevation depression problems. Elevation problems can also go at an angle up. And then you would still just draw an appropriate right triangle to solve them. Next thing we have are rectangular and polar coordinates. We need to know how to convert between them. So we will start with rectangular. We have the rectangular coordinates negative 3i plus 2j. I and j are just fancy ways of saying x and y. I being the x-axis, j being the y-axis. They'll always go xy format. So to convert this to polar form, we have to express it in the vector length and the degree that it's shooting out at. So we'll draw a coordinate plane, right? X, Y. And then we're going to graph this vector. So we go negative 3 on the x-axis, 1, 2, 3. Go positive 2 on the y-axis, 1, 2. That is our point going from origin. So this is what we're dealing with. Now, this vector is a right triangle. We can make it a right triangle on this side, or we can make it on this side. I'm going to go and do it on this side. Now, if I draw this line, the height would be 2. This side would be 3. What I need to find are the length of the hypotenuse and the length of the 4 different lengths that can express this angle, positive, negative, etc. Now the hypotenuse is pretty simple. I can just take 2 squared plus 3 squared. That'll equal c squared. Find the square root of that. So we'll use Pythagorean theorem there. 2 squared is 4, 3 squared is 9. So 13. Square root of 13 will equal c. Alright, so our vector distance is going to be root 13. Now, as far as the angles, how are we going to figure out the angle of elevation, angle of depression? We use our trig identity of tangent, or TOA, T-O-A. That is tangent of theta equals opposite over adjacent, because we have our opposite and our adjacent angles. So we can find this angle right here. The opposite side would be 2, the adjacent side would be 3. So we could say tangent, to continue solving the equation, tangent of theta equals 2 divided by 3. Now, to find the individual angle, this is where it gets a little interesting. We could divide by tangent on each side, right? And then tangent technically has an exponent of 1, so to move it to the numerator of this fraction, it would become tangent negative 1. So what we have now is theta equals tangent negative 1 of 2/3. All right, and that's where that comes from on your calculator. It's the inverse of tangent. So if you think that way, you've already set it out to get plugged into your calculator, and we just type in tangent. Oh, no, I'm sorry. Clear. We go tangent negative 1. Well, there's a glare. Really bad glare. Okay. So we take tangent negative 1 of 2 divided by 3 and parenthesis, hit enter, 33.69. So theta equals 33.69 degrees. Now, we're not done yet. We have to find the 4 angles here. So the hypotenuse is going to be root 13. So remember I said there's 4 answers. We've got this positive answer, then we also have to find the reflection answer. All right, so we're going to have 2 answers that have positive 13. Those will be these positive answers. Then we'll have 2 answers that have negative 13, which would be the reflection of the vector. All right, and then for this positive answer, we're going to have an answer that has the angle of elevation, this one right here, and then we'll have another answer that has the angle of depression, this one right here. So we just found the bottom half, so if we add 180 to this 33.69, that would give us the angle of depression. So we just take 33.69, add 180, we get 213.69, and that is a negative angle or an angle of depression. So one of our answers is negative 213.69 degrees. This is one answer right here. All right, now to find the positive angle, we can take our negative angle, add or subtract 360, and then that would tell us the other angle, which is going to be positive 146.31. All right, or you could just add 360 to this number on your calculator. All right, so these are both of our positive answers. Now the negative answers, or the reflections, are 180 degrees on the opposite side. So to do the angle of elevation, we would add 180 to this number. So when I do that on my calculator, which we're now allowed to use, I get 326.31. That's the angle of elevation. And then for the angle of depression, I would subtract 180 because it's getting smaller. That gives me an angle of negative 33.69. Or the fast way I could have done that is I would have realized that these two angles are vertical angles. So this is the answer for grid to polar. And you know what, I'm going to go ahead and put the directions for polar to grid at the beginning of next lesson's video because we're already at 11.5 minutes.